Hello. In this session, I'm going to talk about statistical inference. We hear a lot about statistical inference when we talk about research methodology, especially social science research methodology in social science. What is statistical inference? Statistical inference is all about making judgments or conclusions about population parameters based on data. And in research methodology, when we conduct statistical analysis, generally there are two ways of conducting this statistical analysis. One is descriptive statistics, and the other one is inferential statistics. And what is descriptive statistics? Descriptive statistics gives a summary of a given data set. That means if a sample data is given, we will find out the mean based on the data, or the median, or mode, or variance, like this. And this is called as descriptive statistics. So what we do is we are limiting this analysis only to the sample data that is given. We are not going to make conclusions about population parameter based on the sample data. So actually it is limited. We do not make any conclusions beyond the data. Everything is limited to the data that is given. And that is descriptive statistics. And in inferential statistics, what we do is we are going to make conclusions about the population parameter based on the data that is given to us. And this process of drawing conclusion about population parameter based on the sample data is called as inferential statistics. So what is this population parameter? I've been talking about population parameter quite a few times, and we will see what population parameter is in a short while. And in inferential statistics, the data should be analyzed and the result should be generalized for application to the population. So that means we take the sample data, we analyze the sample data, and this result will be generalized for the application to the population. And inferential statistics, there are two methods generally. One is called as estimation of parameters, and the other one is called hypothesis testing. So in this session, we will talk more on estimation of parameters and not on hypothesis testing. So estimation of parameters. What is estimation of parameters? Parameters are usually unknown, and therefore we have to estimate the parameter using appropriate sample data. This parameter is actually the statistical measure associated with the population. We'll come to discuss that in a short while. And a parameter, as I said, a statistical measure computed from population data, and a statistic is a statistical measure computed from sample data. So the basic difference between a parameter and statistic is parameter is associated with the population, while statistic is associated with the sample. So what we are doing in the estimation of parameters is we are looking at the sample data, which is the statistic, and based on the statistic, we are assuming or we are estimating the population parameter, or the statistical measure related to population will be computed based on the sample statistical measure, which is statistic. So estimation of parameter can be defined as finding approximate value for unknown parameter using appropriate statistic. So this is what is called as estimation. So when we talk about statistic and parameter, how do they differ? Statistic is related to sample, And if you are going to talk about an example of statistic is mean, and mean, standard deviation, proportion, all these are examples of statistic. Mean is represented by x bar, standard deviation, small s, proportion is denoted by small p. And when we look at parameter, we can see that it is related to population. It comes from the population. And what we do is that the mean is estimated for population parameter as mu, standard deviation. We estimate the population parameter, standard deviation, rho, and proportion. The standard deviation for the parameter is sigma, and for proportion, it is rho. I'll give an example of how we are going to do the estimation of parameters. In estimation of parameter, there are two methods. One is called as point estimation, and the other one is interval estimation. How does the point estimation differ from the interval estimation? We look at a population. We have a population of maybe children. And what we are going to do is that we want to find out the mean height of this population. And the mean height is unknown. So we can say the average height or mean is a parameter. It's a population parameter. So the height of this population, the mean height of this population is an example of the parameter, and that is unknown to us. So we are going to find it out. So what we do in research is like we are going to take a sample from the population. So we may take a few students or few children from this population, and that will be our sample. And what we are going to do is that we are going to measure the height of each child in that sample. So if you are getting like 10 students or 10 children in the sample, we're finding out the height of each student, and we'll divide by the number of the students, which will give us the mean height of students or children in the sample. Suppose we are getting the mean height of the sample x bar as 3.5 feet for the children. So this is the statistic. So that is the sample mean, which is a statistic. And based on the statistic, we are going to find out, or we are going to estimate the population mean, that is the population parameter. What we do is that we are going to say that the mean height of the population is 3.5. So we know the statistic is 3.5, and we are going to say that population parameter or population mean is also 3.5. And this kind of estimation is called as point estimation, because it's a specific point we are saying. If the statistic is 3.5 and the population parameter is also 3.5, this is one of the ways of estimating the population parameter. And the other method is interval estimate. And why we are going for interval estimate? Because point estimate has a problem, because whenever we are going to estimate a parameter, we can say that statistic will be exactly the same as the population parameter. There can be an error, there can be a difference. We can say that when we estimate population parameter using sample statistic, it is never going to be perfect. There will always be an error. We can say that parameter is equal to statistic plus its error. For example, we are saying the population, we can say the population mean in the previous case can be between 3 and 4. Can we say that? Because it's 3.5. So can we say that it is between 3 and 4? The statistic is 3.5. And we can say the population parameter is between 3 and 4. That means there is a range of values. The lower range is 3 and the higher range is 4. So this kind of representing or representing the population parameter is called as interval estimation. And we will compare with a similar example. That is, we have a population of students and we want to find out the mean height of this population. In this case, what we do is that we take a few students from this population, and that will be the sample. And And whatever we did in the previous case, we are going to find out the mean height of this sample. Maybe 10 students or 20 students. We'll find out the height of each student, divide by the total number of students in the sample, and we will get the mean height of the sample. Suppose this is like 3.5. Now what we are going to do is that in this case there is a slight difference when we estimate the population parameter. In this case, population mean, we are going to say that the population mean mu is between 3 and 4. We are not going to say it is exactly as 3.5 because there can be a difference. So we can say that it is between 3 and 4. And usually we say that I am 95% confident, or I'm 99% confident, or I'm 90% confident that the population mean is between 3 and 4. So there is a range of values. The lower range 3 and higher range is 4. Between that, we are saying that the value falls in between these two values. And when we talk about 95% confident, 99% confident, how sure are you about this value, this population mean? When we say 100%, the accuracy is the highest there. When we say 95%, it is slightly lower than 100%. So the confidence level goes down. As we say, I'm 90% confidence or 85% confidence. The confidence level goes down in saying that the population mean or the population parameter falls within this range. So that is what is the relevance of confidence. So confidence interval. And we will talk about confidence interval in the next session. Thank you.